the end as a PDF. Okay. Now, I still
Okay.
encourage you to take notes. It's meant to be dynamic and interactive. It's not meant to be me projecting to you for however long we're doing a lesson. So I might ask you to get involved by answering some questions or working out problems, but I'm definitely, here to help you, whatever you want to work on. So that's we'll get to that in a moment. So everything you see on screen, I'll send you as a PDF at the end of the lesson, and I'm also screen recording. So everything you see will go up to my YouTube channel. I will send you a link to that at the end of the lesson. I just encourage you to subscribe and like your videos. Hey, why not? They're your videos. We can work on whatever you want to work on during this time, whether it's, homework, notes, we can get ahead. If you feel like there's something you missed, I do SAT, ACT stuff too. So I know you're on fall breaks. You may not have anything right now, and that's fine. But
Yeah.
there's always something to work on, and I'm happy to help. Any questions before we get started?
No, I'm ready.
Awesome. So I do jump off camera, and I'll turn yours off, or you can turn it off for the actual lesson and jump back on at the end. But anything in particular you want to work on today, or anything that you think you need a refresher on, or would you like to just do some SAT, ACT, or your dad sent over transformations? We can work on that. It's kind of boring, but we'll do whatever you need to do.
I mean, yeah, I think I think we're gonna move on to whatever's after transformations.
Okay.
But I think I still need to I just want to understand it. So if we ever if it's ever on a unit test or whatever, because my teacher didn't really explain it
Okay.
or didn't
All right.
really
Yeah.
understand it well.
And that's one of the main complaints from a lot of parents and students at your schools. You just don't get a good explanation of things. So, all right, let's do this here. I'm going to turn off your camera. I'm going to jump off screen here. I'm actually going to do something a little bit different. Normally, I do just share my screen, but we're going to go to Desmos Scientific. Have you ever used that before? Do you know what I'm talking about when I say Desmos?
I think so. Yeah.
Excellent. Okay. So we're just going to start with a parent function x squared. Have you seen this before? Parabola that opens up.
Yeah.
Okay. So the first two types of transformations are when you move left and when you move right. Now, do you know if x minus 3 squared moves it to the left or to the right?
I think it's the right.
It is the right. And the reason is maybe not important, but you have to know that inside parentheses, if it's subtraction, it's to the right. If it's addition, it's to the left. Now, I don't know how you're going to remember that, but you as the math student have to remember that. There's a bunch of these transformations to remember. I can get you a little cheat sheet if you want at the end, but that's something that you're going to have to keep in mind here. What about if if it's a number on the outside here? What if it's like +3? Is that up or is that down?
Oh, that's up.
That's up. Yep. And then if we go minus, that's down. All right.
Okay.
And then the last one is the last two. They're pretty straightforward here. Is if I put a number in front of that, is that how would you describe that transformation?
It's changing the slope of it, right?
Kind of. It's considered what's called a vertical stretch. So it's like pulling up. So let me try to explain that here in more detail. So this point is on the first graph, and then this point is on the second. It's pulled straight up. Do you see that? How it's pulled straight up?
Yeah.
Okay, that's a vertical transformation. So if I put we can put another number. If I go 4, you'll see that it's pulled up. That same point is pulled up even more. Is that okay? Is that clear?
Yeah.
All right. So now the last one is if I put a negative in front of the variable. Do you remember what that happens? What happens here?
Oh, that's a vertical reflection,
Yes,
right? Okay.
over the y-axis or reflection over the y-axis like that. All right, very good. So let me go back to this screen. We covered most of the basic transformations here. Now, from the other students that I'm helping in at your school, what I know is you've done a lot of root functions recently. Does that sound about right?
Yeah.
Okay. So let me just put one in front of you here, and let's see if you can give me the list of transformations. There are 4 total. The order does matter, but I'll take them in any order. Can you tell me any of the four transformations that you see?
Yeah, vertical reflection.
Okay, so we would say reflection over the x-axis. Vertical's okay,
Okay.
but it's preferred to say the axis. So um, that being the horizontal axis, you are going vertically, but it could be unclear. What else do you see?
Um, it would be left one.
Okay, left one, that's the first one.
Oh, and vertical stretch of three.
Vertical stretch of three. Anything else?
Down four.
Down four. Okay. All right, very good. Now, one of the reasons that you would want to know these transformations is to graph it. Were you guys typically graphing these?
Hold on, my mom's trying to talk to
Sure.
me.
No problem. Let me know when you're back.
Okay, I'm good. I'm good. Sorry.
Okay.
Uh,
Were you guys graphing these in class?
yeah.
Okay, there's two approaches to graphing. One is to make a table. The second is to use the transformations. You're using the transformations with the table, but sometimes if it's a rough sketch and you know that like this is the root function, you can manipulate the graph pretty clearly. You're going left, you're going down, you're pulling it up, you're going over the x-axis. So like, do you have a preference? And if you don't, I'm going to encourage us to do a table today for some of these.
I don't. Yeah, I wouldn't usually use a table, but
Okay, well then, so that's good. Maybe we'll try something a little different here. The parent function for a root function, there's only certain numbers that you can take the square root of. Can you give me some of those numbers? Maybe start from the
yeah.
smallest number. Go ahead.
Um, can you do one? Does that? Because it's just one, right?
Yep, you can take the square root of one. Take the square root of zero, which is zero. What's the next square root that you know?
Four.
Okay, square root of four is two. Square root of nine is three.
Yeah.
Okay, and this is where this like left stretch, all this stuff matters here. Now, when we graph this, or this new one from the parent function, what we have to be careful of is like making sure we know what these do, because the plus one could like make you think, well, I'm going to add one to all these. But the problem is there's only certain numbers you can take the square root of. Okay, you can't take the square root of two. That's just it's a tough number to take the square root of. So left one means you're subtracting one from all the x values, minus one, zero, three, and eight. To get the y, you've got to put each of these x values into this function here. Could you do it for any of these numbers? Doesn't matter to me which one you pick, but could you try one and let me know what you come up with?
Replace it with x.
Yes.
Okay. 0 plus 1 is 1, so square root of 1 is 1. And then
Okay, keep going.
would you multiply it by -3?
Yes, exactly.
So -3, so -7 would be the answer,
Very
I
good.
think.
I'll do -1. Okay, -1 plus 1 is 0, square root of 0 is 0, anything times 0 is 0, minus 4 is minus 4. So either can you do 3 or 8 for us, please?
Yeah. So 4, so 2, so -6, -10.
Yes. Okay. So you're starting to get a picture of what the graph looks like, right? -1, -4, 0, -7, 3, -10. You're getting a sense of the shape of the graph here. All right.
Wait, why
And
did you
for
choose those x values though?
good question. So we're addressing this whole point of like, which of these transformations affects X and which affects Y? So left one definitely affects X. When you're going down, that affects the Y value. Vertical stretches, vertical is the Y. Reflection over the x-axis is the y. So the only thing that affects the x is the left or the right at this point that you know about. And left one means to subtract one from each x. The other answer is that these are the only ones that you can take the square root of when you add one to them.
Oh, okay.
Does that make
All right.
sense?
Yeah.
Okay. Um, did you guys talk about domain and range?
Not really.
Okay, we'll save that for a little bit. Okay, so let's do another problem here. Let's say it's g of x equals negative square root x plus 2 um, plus 3. Can you give me the three transformations here, please?
Reflection over x-axis.
Okay,
Uh, left 2 and up 3.
good. All right. Now, you've probably heard me say this a couple times now. The order matters. Your teacher, your class may not emphasize it, but in a future class, it will matter. And if you play sports, you know that your movement matters all over the place. It's not just do whatever you want. Um, you actually already know how to do the order because when you evaluated this last one, you were doing it for me. You said, all right, 0, I'm going to first add 1. Then I'm going to take the square root. Then I multiply by 3. Then I subtract 4. That's how you come up with the order. The order is based on the order that you would evaluate. So if you're ever unsure,
Okay.
that's how that's decided. So again, normally your parent function is 0, 1, 4, and 9. If you put 0 in for x, you get the square root of 2. That's no good. So left 2 means you're going to subtract 2 from each of these x values. So what are the new x values in this table?
So first is -2, so
Hey,
uh
give me the rest of them.
so yeah, so hold on. So wouldn't it be -1?
Let's keep going.
Um 2
Okay. And then
and 7.
very good. Okay. Now I want you to calculate the rest of this table, please.
Okay. Is it just 3 for the first one?
It is 3. Yes.
Um 1 2
Okay. Keep going.
1.
Very good. And then the last one is 0.
Yeah.
Now these do not always go in order like this. Just don't make that mistake of thinking, okay, I've got it. So let's just do a quick table, quick graph here. So -2, 3, -1, 2, 2, 1, 2, 3, 4, 5, 6, 7. So in terms of graphing it, make sure you have like a reasonableness to it, which is like make it kind of have a curve. Don't draw straight lines if they're grading on that. Okay, so let's look at some other functions here. I mentioned some earlier. So you need to know there's like a list of like 10 parent functions. Do you remember the names of any of these, or do any of these look familiar to you?
I mean, like I don't really know specific like
That's
names.
fine.
I mean, yeah, okay.
Linear, line, quadratic, cubic, root, absolute value, cube root. There is the expectation that you know all these at some point in the course, whether that's, this week or next month or, you know, whatever
Yeah.
it is, like at some point you're going to be expected to know all these. They also have their own parent function. So like if I asked you to graph the absolute value of x, well, you may know that the graph is a v. To do the transformations, you need the parent function. And this is where, you're gonna have to make some note cards or, just they're memorize it, or maybe just do enough of them, it just becomes familiar to it. Because we're going to do a problem where we do the same types of transformations we just did for the root function. So maybe do something like this. Let's say h of x equals -3 absolute value of x plus 6. Um, all right, what are the transformations that you see here? What does the 3 do?
Um, hmm, that would be the vertical stretch or shrink. I get those
Stretch,
two mixed
stretch.
up.
Okay, so let's clarify that. So the notation is like this: a f of x, a greater than 1 is a stretch. Okay, when a is between 0 and 1, that's a shrink.
Okay.
So if it's 1/2 absolute value of x, this is a shrink by 1/2. Now that's not the exact right language, but it's what your school uses. So we'll go with that. Now there might be some confusion. What if it's like -1/3 absolute value x minus 1? So the a does not include the sign. So this is a shrink by 1/3. The negative means a reflection over the x-axis. Is that okay?
Yeah.
All right. So let's go back to this problem here. There's no shift left or right, so we're going to use the original function. Okay. So for this first one here, you're putting in the number for the absolute value. So we'll do it for -1. 3 times absolute value -1 plus 6. Absolute value always returns positive. So this is 1. -3 times 1 is -3 plus 6 ends up being 3. -3 absolute value of 1 ends up being the same thing. So for certain functions, you get this symmetry. Have you seen that before in class?
Yeah.
Okay, you actually get the same thing for these other two values. Now, the reason you get the symmetry is because this middle point here is the vertex. Could you calculate the vertex for us, please? Or maybe you can just tell us from the graph
Yeah.
here
Just
or from the
6.
function. Just 6, right? So when you know the vertex, if you go too smaller and too larger, there's always going to be this symmetry. So I'd like you to evaluate the function either at 2 or -2 and tell me the y value. And if you do it correctly, you get the other one as well.
I think it's just 0.
It is 0. Good. So this idea of this vertex, that symmetry, it applies to quadratics and absolute values. So they typically pair these up when you're learning them. Maybe you saw that in your class. Maybe.
Yeah.
Okay. Like I said, this isn't the most interesting. This is not the most interesting topic. It's just a topic in this. All right. So let's say you get some of this 4 minus x plus 2 squared. This has 3 transformations. Sometimes the instructor will present the problems like in the wrong form, like this, where you really don't like it this way because you don't know what this 4 is doing. So if you rewrite it, and this is something you'll do a lot in calculus and other courses. If you rewrite it, this is just a, a way to make it more presentable. Sometimes the transformations are easier to see. So what would the 3 transformations be here?
Um, it would be reflection over x-axis.
Okay, good.
Uh, left 2, up 4.
Up 4. All right. So the normal parent function for a quadratic is much the same as the absolute value. And you get this symmetry again. Okay. The way to decide where to start the table is always the vertex. You saw me do that in the previous problem. Can you tell me the vertex of this parabola here?
Um, so I'm sorry, did you say it's gonna be on its 0, 0, or
No, that's the parent function. The hint here is that the vertex moves based on the left and the up or down.
uh mm, I'm not sure.
All right. So I'm going to give it to you here, -2, 4. Now we want two
So
smaller and two larger. And what you might notice is that we're subtracting each of the x values by 2 to get this. Is that okay? Clear?
yeah.
All right. So to get the y values, again, you don't have to do all of them. You just have to do some of them. Why don't you evaluate k of -1 for us, please? Tell me what you come up with, please.
Uh, -1 plus 2 is.
Say that one more time. Sorry, I didn't quite hear
I'm
you.
sorry, I'm thinking about it.
Okay.
So would you
You do the part in parentheses first. -1
okay,
plus
so
2.
yeah, so, so 1, and then do you square
Negate
it?
it. Well, yeah, 1, and then you square it. That becomes 1.
Yeah,
Then
so
you
okay, so
negate
it's
it.
okay, so 3.
Yes. All right. Can you do it for 0 now?
Uh, 0 is the answer.
0. Okay. So this symmetry really helps when you're graphing it because you what you don't want to do is have to like actually evaluate all 5 points. That could take a while. And that just becomes problematic. So you got -4, 0, -3, 3, -2, 4, -1, 3, 0, 0. When you're graphing quadratics, you want to make these nice and smooth. Um, well, something like that. All right. And then we just talked about it, but the vertex point is right here. That's the min or the max. And I actually don't exactly know where you're going in this class. Because I don't think you guys have fully done transformations, but maybe you are done. I'm not sure. So um, we are going to stop here for now. Try out lessons about 25 minutes here and then some time to talk and give some feedback and talk about scheduling. So let me go ahead